In this video, we will cover optional components that you can insert into your application and down into your RTOS to give you various types of information that we don't provide by default. CTView sits on top of the RTOS, and it will give you performance information regarding service calls. However, because we don't always have access to the source code of a given RTOS, we may not necessarily be able to get in there and insert points for capturing performance data from, and say, the interrupt handlers and things of that nature. So for this particular demonstration, we're going to be looking at these buttons right here, what they mean and how you can use them in your application to get more detailed information about what's going on down in the kernel, we'll say. So initially, this is the variables button. So you can insert this into your application at any given point in time. And anytime your application runs that piece of code, it will show you the value of a variable that you have decided to look at. And one of the things that you can see, it's represented by a V here, and this particular one is well, there's this context switch there. Let's zoom it out so we can get to it, or zoom it in so we can get to it. We'll zoom in here, and as you can see, the markers start to separate, and there is the variable. So basically, we have the variable thread time, which is in task 0, and it has incremented 12 times. And it gives you both the decimal and the hexadecimal value for the variable. So let's move on to function pointer. As you can see, when you click this and you click the variables as well, you can see that those disappear, so you can enable them and disable them in order to minimize the amount of stuff that's on the screen, or to clear it up so that you can see other stuff. The function trace, you can see that there's one there. Essentially what this is there's a function called add two numbers, and we've just inserted a test point in there that allows you to mark when that function occurred. Now that's different than, let's say, the this function here, where we actually have well, that's a context switch. It's different than where you're actually going to monitor the time of a function. It's just going to give you the actual time that it occurred. So you can stack these up. If function A calls function B, which calls function C, you'll be able to see that on your timeline. So that gives you a trace back through that call sequence. Stack overflow, as you'll see, notice right here, the S represents that. It gives you the stack pointer at the point of stack overflow, and you can turn that off or on. Obviously, it crashed the system, so that's where it stopped at. So that gives you a good indication of where a problem might be. And as you can see, if you do the trace on this thing, if you look at the trace and you let's see, if you look at the trace on it, you'll notice that the last thing that happened was something in the queue. So it looks like it did a context switch right there. That's went into the scheduler, and it measured how long the scheduler took to determine what thread was going to run next. And then at this point, it for some reason, this particular RTOS hit that twice in two different areas of the scheduler, and I guess maybe it looked for interrupts, or not interrupts, but for some other service that it might have needed to execute. It took it 3 microseconds to determine that, okay, task 4 is going to run, and then task 4 went to do something. As you can see on the timeline here, it was executing, and at this point in time, which is we'll say 12, I can get it right on it there, 12 seconds, 200 milliseconds, you have a stack overflow. Okay, so now let's zoom it, let's go all the way home and zoom it back out. Next one is the switch time, which is going to be your context switch. That's these markers right here that you can see going on and off. So let's just pick a point here and zoom in so that we can see what's going on. This RTOS, apparently what it does is it hits the scheduler to determine what's going to run next. Once it's decided what task it's going to run next, the scheduler then loops again to see if there are any other maybe a hisser, high-level interrupt service routine, or something of high priority that needs to run before this actual context switch occurs. So they do a check. It might even be some pending interrupts or something like that. You really just don't know. I'd have to go back and look into the scheduler to see what it actually does. But there are 2 hook points in there in 2 different loops, and so we hooked it up on both of them, and this is what the result was. So anyway, that's primarily what these buttons up here do. They give you the ability to insert performance data capture points and things inside of your application. And you can see we've got some alarms here. Looks like the semaphore is waiting approximately 4 seconds, a little over 4 seconds before it's actually been able to obtain it. And this is a mutex that is also going to wait that waited approximately 4 seconds in order for it to capture. Anyway, that's what these buttons are for. Good information for you to insert into your kernel and your application so that you can get more detailed information about what's going on with them. Thank you for watching, and we hope to do another video soon.